So yesterday we covered this whole page of notes, and it was truly a lot of information. Yesterday we learned how to graph quadratic functions, especially that are in standard form. Um, After going through all of this, I ended up creating or writing on the board the learning target. So yesterday and for this week and next week, our goal is to be able to graph quadratic functions. How are we going to be able to do that? Our success criteria will be, first, you got to know your standard form, y equals ax squared plus bx plus c, right? Um, Sometimes you won't have a trinomial. Sometimes you may have just a binomial, right? Maybe you just have the ax squared plus bx. Or maybe you don't have a middle term. You might just have a ax squared plus c. But those are still parabolas, right? Those are still quadratic equations. But anyway, we need to understand that ax squared plus bx plus c, the a value is going to be the number in front of x squared. The b value is the number in front of x. The c value is the number without any x's, right? That's the first thing to know to be able to locate a, b, and c. After that, to be able to graph a parabola, you need to know what vertex means. The vertex is the most important point of a parabola. It's either the highest point or the lowest point, okay? How do you find that vertex? Well, if you know your quadratic trinomial equation and you know how to find a, b, and c, you could use this formula. You got to know the vertex formula, x equals negative b over 2a, and you get the b value from this number in front of x if there's a middle term. If there's not, then b would be 0. But if there's a middle term with an x, that b value, the number in front of x, is your b, and you plug that in right there. The a value is simply the leading coefficient of your standard form quadratic trinomial. The a goes right there. So you plug it in, and you'll be able to find the x value of your most important point, known as the vertex. Now, keep in mind that the vertex is a coordinate. So once you find that x value, you could plug the x value. Like, let's say you did this formula and you got x equals 2. X equals 2. This whole fraction ends up being 2. How do you find the y value? You simply take the x value of 2 and you put it right there on that x and right there on that x, and you do the math with 2 instead of x's if you got x equals 2. In other words, you just plug in x into the x's to be able to solve for y, and then you'll have your vertex, the most important point, which is the xy value, which is the highest point or the lowest point of your parabola, depending on if it opens up or down. The a value tells you if it opens up or down. If the a value is positive, the parabola will open up. If the a value is negative, the parabola will open down. If you throw something up in the air and it reaches a max height, then it comes back down, that's because the a value of your parabola is negative. It goes up and then it comes back down. So if the a value is positive, it opens up. If the a value is negative, it opens down. That's pretty easy to remember. If you're running a race and you win first place, you're going to have your both hands up in the air. That's like a parabola opening up. That's a positive feeling. If you lose a race, you're going to have both arms down, which would be a parabola opening down, which is a negative feeling. So if the a is positive, it's opening up. If the a is negative, it's opening down. Anyway, we learned all this stuff yesterday, and I wrote it on the board because technically you need to know these things to be able to successfully graph a quadratic function. There are a couple of things that I missed yesterday. I missed how to find the y-intercept, but technically we're supposed to learn that, or we're supposed to remember that from semester 1. How do you find a y-intercept? You set x equal to 0 and solve. So if you want to find the location of where your parabola crosses the y-axis, simply put x equal to 0 and solve. And it's really easy to do that when you have standard form quadratics. Because if I say find the y-intercept, you set your x's equal to 0, and 0 squared would be 0. Anything times 0 is 0. Anything times 0 is 0. So when you plug in 0 into your x's, when you set x equal to 0, everything cancels out except for your c value. So your y-intercept will be 0, comma, and whatever that c value is on a standard form quadratic trinomial equation. What else? Yesterday, we also learned that your a value, let's go to yesterday's notes. Your a value, not only does it tell you if it opens up or down, but it also tells you if it's wide or narrow, okay? And we'll get to that in a little bit. But the main idea for today is to know if the a value is positive, it opens up. If it's negative, it opens down. But we also need to eventually conclude that the a value tells you if your parabola is wide or narrow. So if you have a parabola that has the a value of 1, the very first parabola that we graphed yesterday was y equals 1x squared. The a value is 1. It's super easy. We graphed it with the table since we didn't know any other method. We just started plugging in 0. 0 squared is 0. So when you plug in a 0, you get out of 0. Plug in a 1 right there. 1 squared is 1. So when you plug in a 1, you get out of 1. Plug in a 2 right there. 2 squared. 2 times 2 is 4. So when you plug in a 2, you get out of 4. Plug in a 3. 3 squared is 9. Okay, now you didn't have to stop right here. You could have kept going. Plug in a 4, get out of 16. Plug in a 5, get out of 25. But obviously, the location 416 is 1, 2, 3, 4. 16 is off the graph. But it doesn't mean that it doesn't exist. It will pass through the parabola. It will be on the parabola. That's why we put arrows on it. Okay, so one other thing that we missed yesterday was that we forgot to state the domain and range of each of these parabolas. Okay, I hope we remember that the domain are your x values and your range are your y values. So like I said, the x values, I stopped at 3 because if I went to 4, it was off the graph. But the bottom line is I could have plugged in 4. So this graph does exist at 416 or at 525 or at 636 or at 10, and 10 squared is 100, way off the graph. So this parabola does exist to the right and to the left forever. So the domain would be x equals all real numbers. That's one thing that we missed yesterday, right? So please go to this question, that first one that we graphed, and go ahead and write down that the domain is x equals all real numbers. Now the range are your y values. And as you can see, this parabola right here does not exist down here at negative 10. It doesn't exist at negative 5. It doesn't even exist at negative 1 on the y. It starts existing at the y value of 0 and above. So the range is clearly y is greater than or equal to 0. Okay? So if your parabola would have been opening down with the vertex at 0, 0, it would have been y is less than or equal to 0. So those are the couple of things we forgot to mention, like the y-intercept and also domain and range. We forgot to mention that yesterday, so we need to know that stuff today. What else? What were we doing here? Oh yeah, we were talking about that when your a value is 1, it's going to be exactly this width. It's not going to be any wider. It's not going to be any narrower. It's going to be exactly precisely this width, which means that whenever you have an a value of 1, you're going to be able to use the pattern 1, 1, 2, 4, 3, 9. Okay, once you find the vertex, that is. So like, let's go to this guy down here. Okay, this guy, step 1 was to find the vertex. And what is the vertex? Well, to find the vertex, like right here, you could already see what it is. But how did I find this vertex? You got to use the vertex formula, just the way it says right here on the board. The vertex formula is x equals negative b over 2 times a. So when you use negative b over 2 times a, and you replace the b with parentheses and the a with parentheses, and you actually plug in the b value, and now notice that there is no bx term. It's ax squared plus bx plus c. The ax squared, the a is 1. There is no bx term. There is no middle term. So the b is 0, and the c is negative 3. So since b is 0, you plug in a 0 where the b is at up here, and the a value is 1, plug in a 1 down there. So you end up with a negative 0 over 2 times 1, which is 2. So negative 0 divided by 2, that's simply 0. 0 divided by anything is still 0. So the x value is 0 of the vertex. That's where I got this first number of my vertex. The x value is 0. We don't know this one yet, but how do I find this one? If you know the x and you want the y, all you have to do is plug it in. So plug in 0 into the x, right? X is 0. Plug it in. So you're going to plug in 0 into the x. So I rewrite this thing. Y equals x squared minus 3. There it is. Y equals x squared minus 3. But instead of x, I put parentheses. Why? Because I know what x is. X is 0. And I plug in 0 into the parentheses. So then I do this math. 0 squared is 0. 0 take away 3 is negative 3. So the y is negative 3. So now I know my entire vertex, the x value and the y value. Okay? The x value came from here, and the y value came from here. Okay? Now that you know the vertex, first of all, that could be a question on its own on a quiz. Find the vertex. You would type in 0, negative 3 in parentheses, no spaces, and that'll give you the correct answer. But you're supposed to plot your vertex, 0 on the x, negative 3 on the y. You put a dot there. The next thing to state, the second thing to state would be the axis of symmetry. The axis of symmetry is the vertical line that goes right through the vertex. So wherever your vertex is that's where you're going to draw your vertical line. So like, let's say your vertex was not 0, -3. Let's say the vertex was 9, -1. Let's say down here. Then you would draw your vertex, your axis of symmetry right through that vertex, if that were the case. But we could see that the vertex is 0, -3, so we drew the axis of symmetry right there. Now, I may ask you to state the axis of symmetry equation, and that's simply going to be x equals whatever the x value is of your vertex, in this case 0. So that vertical line is the equation x equals 0, okay? Now, we need more points. So you could go to an input-output table, an XY table, but that's kind of a waste of time, especially when your A value is 1. Because we said if the A value is 1, it's going to be exactly as wide as this one, which means we could use these coordinates, the coordinate 1, 1, the coordinate 2, 4, and the coordinate 3, 9. We could use those coordinates as a pattern when A equals 1 from the vertex. Okay, so down here, we have the vertex and the A value is 1. So we could use the pattern 1, 1, 2, 4, 3, 9 from the vertex. So imagine I don't have any coordinates, right? And I want more coordinates. I go from this vertex, I go 1, 1. That means 1 over and 1 up. Okay, 1 to the side and 1 up. If you're thinking, do I go to the left or to the right? It doesn't really matter. You're going to reflect it to both sides anyway. So 1 over 1 up from the vertex, 1 over 1 up. Back to the vertex, 2 over 4 up. 2 over 4 up, put a dot right there. Go back to the vertex, 3 over 9 up. 1, 2, 3, 9 up right there, boom. And then once you have these red dots, you could mirror them over to the other side of the axis of symmetry. So it's 3 units away. So go 3 units this way and put that dot there. 2 units away, go 2 units this way, put that dot there. 1 unit away, go 1 unit this way, put that dot there. You have your parabola. Cool? That's how you graph. Okay? Once again, how do we graph? Step 1, find the vertex. How do you find the vertex? Use a formula. Find your x value. Plug in your x value to find your y value. Then you have your vertex. After that, graph your vertex. Draw your axis of symmetry. State the equation of the axis of symmetry. And then after that, you need more points. You could use a pattern 1, 1, 2, 4, 3, 9 if your A value is 1. If your A value is not 1, like look up here, we did this one yesterday as well. The A value is not 1. So once we found the vertex, we needed more points. So you could just go to an XY table and you could plug in some easy numbers and pull out some answers. And those will be coordinates. And each coordinate that you find, you could just mirror it over to the other side. So right here, we cannot use the pattern 1, 1, 2, 4, 3, 9, because that's not a positive 1 or a negative 1. That's a -3. Tomorrow, I'll teach you how to modify the pattern so it could work with the A value of -3. But right now, we're not using the pattern on this one. Right now, we're using just the input-output table. So, for example, if I asked you to find the y-intercept, right? How do you do that? If you forget, you could just look at the board. How do you find the y-intercept? By setting x equal to 0 and solving. It's going to be 0, comma, a certain value. So if you look at this function right here, and I say set x equal to 0, everything becomes 0 except the c value. So 0, comma 5, because 5 is a c value, that's your y-intercept. So if you know your vertex and you know the location 0, 5, you get that yellow dot, and you could map it over to the other side of the axis of symmetry, and you could already have your parabola that's pretty accurate right there, okay? If you want this point or that point, you could just plug in more numbers, like plugging in 2 will give you out of 5, right? And you could plug in 2 by plugging in 2 right there, doing the math, you get out of 5, right? So you could find more points by doing the input-output table. But here's what we want to be able to answer whenever we have a quadratic trinomial equation or a quadratic binomial, any quadratic. You want to be able to state the vertex. You want to be able to state the axis of symmetry. You want to be able to state the y-intercept. You want to be able to use the pattern if possible. If your A value is 1, you could use a pattern 1, 1, 2, 4, 3, 9 from the vertex. You want to know that the A value, if it's positive, it's opening up. If it's negative, it's opening down. You want to be able to use an input-output table. You want to also be able to state the domain and range. So everybody look at this parabola right here. What is the domain of this parabola? The domain is x equals all real numbers. Remember, the domain to any parabola. It doesn't matter if it's opening up or if it's opening down, if it's really wide opening down or really narrow opening down, the domain is always going to be x equals all real numbers. I already had it written down right here, sorry. The range are your y values. So where are the y values of this parabola? Will the y values of the parabola be at -10? Eventually, yeah, the arrows mean that it'll get to -10 on the y. Do they exist at 0? Yes. Do they exist at 5? Yes. 6? Yes. Where do they? Does it exist at 10? The parabola does not exist at the y value of 10. It goes up so far, reaches a max height, and then it comes back down. So it does not reach the max value of 10. What's the max value of this parabola? Anybody? 8. So the parabola exists at the y value of 8 or below. That's why the range is y is less than or equal to 8. Okay? Cool. So that's what we want to be able to do. We want to be able to state the vertex. We want to be able to state the axis of symmetry. That is a vertical line right through the vertex. You want to be able to state the domain and range. You want to be able to state the y-intercept by setting x equal to 0. And you want to be able to also use the pattern if possible. Let's flip this paper over. And you should see some practice problems. Now, if you look at these, I have 4 on the left column and 4 on the right column. I'm going to do the first 2 with you right now. Number 1, what is the very first thing to be able to find when you want to graph a parabola? What's most important? I mean, you could even look, if you're totally lost, look at the wall. Well, you're able to recognize A, B, and C. If you recognize A, B, and C, you could use a formula to find the vertex. So let's find that vertex. Okay, let's all write down step 1, vertex. The vertex is the most important point. It's the most important coordinate. It's either the highest point of your parabola or the lowest point of your parabola. So how do we find that vertex? It's on the wall right there. X equals -b over 2 times a. And when you use a formula, I recommend replacing your b and your a with parentheses the way I just did. That way, when you identify the a, the b, and the c, you'll be able to plug it in. The a happens to be 1. The b happens to be -2. The c happens to be -1, which is not even in the formula. Who cares about c? But anyways, the b value is -2, so you put it right there. The a value is invisible 1, so you put the 1 right there. And what do we have here? Up on top, we have a negative, which is really a +2. And on the bottom, we have 2 times 1, which is also a +2. Are you with me? So what is the x value really? 2 over 2 is 1. So we just found that the x value of the vertex is 1. So here's my x value of my vertex. That is the number 1. Okay? Maybe I shouldn't put, that looks like a fraction. Let me just write down a 1 right there. There it is. How do I find my y value if I already know my x value? Anytime you have an x and you want the y, all you have to do is plug it in. So my equation reads y equals x squared minus 2x minus 1. That's what I'm going to write. Y equals x squared minus 2x minus 1. And yeah, whenever I said the word x, instead of x, I put parentheses. Why? Because I already know what x is. X is 1. So instead of x, I'm actually going to plug in the number 1 into both of those x's. So what do you do with that x value of 1? You plug it in to find y. All right, so let's plug it in. Let's work it out. What is 1 squared? That's 1. What is 2 times 1? That's 2. But of course, there's a minus sign in front of it. And what about the minus 1 right here? Just bring it down, minus 1. So y equals 1 minus 2 minus 1. So what is 1 minus 2 minus 1? Y is going to equal -2. So we just found the y value of our vertex. Ladies and gentlemen, that's the hardest part right there, finding the vertex. That is the first thing that they want you to do. They want you to find the vertex. That's the hardest thing to do. You have to use a formula. You got to get that x value. You got to plug it in to find the y. Now that you know your x and your y, you finally know that most important point. You see, the vertex is the most important point because it's the highest or lowest point of your parabola. So right now, let's graph the coordinate 1, comma, -2. So 1 on the x, -2 on the y. Let's put a dot right there. And that is your vertex, okay? The very next thing to do, if you're totally lost, look at the board. Well, we have vertex, and then after that, the axis of symmetry. Okay, we already found the vertex. So what is the axis of symmetry? That's simply the vertical line that passes right through the vertex. I always draw it as a green dotted line. What is the equation of that axis of symmetry? The equation is simply x equals the x value of your vertex. What's the x value of your vertex? 1. So the equation of the axis of symmetry is x equals 1. And that could be a question that I ask on the quiz itself, all right? Now, we need more points. We need more coordinates. I already know that this is opening up or down. Is it opening up or down? It's opening up because the a value is positive. If the a value is positive, it opens up. If the a value is negative, it opens down. That vertex is either your highest point if it opens down or your lowest point if it opens up. And the a value tells you if it opens up or down. If the a value is positive, it's opening up. It's kind of like if you won a race. Big smile. Yay, right? Okay. Or if you lost a race, you're going to have your arms like this, right? So positive opening up, negative opening down. That was ridiculous. I apologize. Anyways, I hope that helps. Positive, if the a value is positive, it's going to open up. If it's negative, it's opening down. And that could even help you out without looking at the graph. You could be like, well, the domain is always x equals all real numbers. That's like a free point. But the range, where's your parabola at? It's either going to be above a certain y value or below a certain y value. Now, we know that this vertex is either the highest point or lowest point. We know it's opening up, so that must mean that it's the lowest point. So you already know that your range is going to be y is greater than that y value, greater than or equal to that y value of the vertex. So y is greater than or equal to -2 without even graphing it. But of course, I want to graph it, right? So let's graph it. We need more points. You could go to an input-output table, or you could realize that because the a value is 1, we could use the pattern, and it says up here, check it out, know how to use the pattern 1, 1, 2, 4, 3, 9 when your a value is 1, okay? So when your a value is 1, you're going to be able to go from the vertex, it says from the vertex, you're going to be able to go 1 over and 1 up, and then you go back to the vertex 2 over and 4 up, then back to the vertex 3 over and 9 up, okay? So right here, the a value is 1, so I could go 1 over, 1 up. Let me actually just write down the pattern again. Pattern, 1, 1, 2, 4, 3, 9. And that's only if your a value is 1, which it is. A value is 1. If you had a 3, you wouldn't be able to use this. But it's a 1, you could use it. So you're going to go 1 over and 1 up and put a dot right there. And then you're going to go back to the vertex. And now you're going to go 2 over 4 up. So 2 over 1, 2, 3, 4 up and put a dot right there. And then you could go 3 over 9 up from the vertex. 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm 2 units off the graph. I don't have to do that point. But I mean, I'll just put it just so you could get an idea. That would be somewhere right here, I think. Okay. So when you start graphing your parabola, it's going to curve, and you could point it towards that point that I got up here, which was at the 3, 9. That's not the coordinate 3, 9. It's the pattern from the vertex 3 over and 9 up, okay? Now, you want the points on this side. All you got to do is map them over to the other side, or you could even use the pattern 1 over 1 up, but just going in the other direction. I think it's easier to actually map them over. This is 1 unit from the axis of symmetry. Go 1 unit this way, put a dot right there. And then this one is 2 units away, so go 2 units this way, put a dot right there. And this last one that's up here 2 units off, it's 1, 2, 3 units from the axis of symmetry. 1, 2, 3 units would be right here. I guess I'll put that blue dot up there just so we could see that it points towards that blue dot, okay? So here's our perfect parabola. What else could we state? We already stated the domain's x equals all real numbers. We already stated the range is y is greater than or equal to that vertex, which is the minimum value because it's opening up. We could also state the y-intercept, right? The y-intercept is the location of where it crosses the y-axis. You could clearly see that it crosses right here. Here's your y-axis, crosses right here. That location is 0, -1. Now, let's say you didn't have the graph. You just had the equation. It's really easy to find the y-intercept. All you have to do is set x equal to 0. That's what it says right here on the board. You know how to find the y-intercept by setting x equal to 0 and solving. So you're going to set x equal to 0. And imagine that, putting a 0 right there and there, this whole thing becomes 0. 0 minus 1 is -1. So when you plug in a 0, you get out a -1. You found the y-intercept without even looking at the graph. So you could find the y-intercept by looking at the graph, or you could find the y-intercept by setting x equal to 0 and solving for y. And that's all I want to, that's a lot, but you got to be able to state all those things. Reading through the instructions, yes, you need to find the vertex. How do you do that? Well, you got to use a formula. It'll give you the x value. You plug in x, you find the y, there's your vertex, you found the vertex. After that, you could draw a vertical line right through that vertex. That's called the axis of symmetry. If you want to state the axis of symmetry equation, it's simply x equals the x value of your vertex. So because the x value is 1, it's x equals 1. That's your axis of symmetry equation. So you found the vertex, you found the axis of symmetry. We could find the y-intercept. We did find the y-intercept. How do you do it algebraically? You set x equal to 0, put a 0 right there for x, a 0 right there for x, solve for y, it'll be your c value, so 0, -1. Or if you could see it visually, you could say, oh, that's the location 0, -1, where it crosses the y-axis. What else? It says state the domain, which we already did. Domain's right here. State the range, we already did. Y is greater than or equal to -2. And that's a lot of information we need to state, but that's what we're doing, okay? So let's check out number 2. Let's start by finding the vertex, and we're going to use the formula. And when we use the formula, we're going to rewrite the formula, but with parentheses. And then we're going to identify the b value, the a value, and the c value. Okay, the a value is the number in front of x squared. The b value is the number in front of x. And notice that there is no x term. So there is no b. So b is 0. And the c value is the number without an x. So the c is 3, which c is not even in the formula. So the reality is b is 0 and a is -1. So when you have x equals -0 divided by -2, that's really just 0 divided by anything is still 0. So we know our x value is 0. So the x value of the vertex is 0. You need the y value. All you have to do is plug in that x value of 0. So when you plug in 0 into there, it's going to read y equals -x² plus 3. Of course, I'm going to plug in 0 right in there in with parentheses. So 0 goes right in here, and you will get y equals +3. So the y value of your vertex is 3. The x value was 0. We plugged it in, and the y value is 3. That's our vertex. That's the most important point. So let's graph that most important point, 0, 3. 0, 3 is up here. You draw your axis of symmetry right through it. And then from there, you need more points, and you could easily use the pattern 1, 1, 2, 4, 3, 9, because the a value is -1. Because the a is -1, you could use a pattern 1, 1, 2, 4, 3, 9, but instead of opening up, it's going to open down. So 1 over 1 down would be right here, and then 2 over 4 down would be right there, and then 3 over 9 down, 3, 4, 5, 6, 7, 8, 1 unit off would be right there. I'll just draw it because it's only 1 unit off. And you could map those red dots over to the other side. 1 unit, 2 units, and down here, if you had a graph that's big enough, it'd be 3 units. So 1, 2, 3, it'd be down here, the reflection to the other side. So we're going to graph that parabola. and we're done. All you got to do is state other things like the y-intercept, set x equal to 0 and solve, but you could already see that it crosses at 3. So 0, 3. Right here, the vertex is the same answer as the y-intercept. That's just a coincidence. What else could we state? The domain and range. The domain, x equals all real numbers. Any parabola is going to have the domain x equals all real numbers. The range is y is what? Y is above a certain y value or at a value and below. It's below, so it'd be y is less than or equal to 3. So this parabola reaches up to the y value, the max height of 3, and then it comes back down. So how do we state that in terms of an inequality? Y is less than or equal to positive 3. And that's about it. If I ask you for the axis of symmetry equation, that would be x equals the x value of your vertex, which happens to be 0. Okay. So we have the vertex that we stated. Well, actually showing all this work as well. And then we have the axis of symmetry equation. We have the y-intercept. We use the pattern. And we have the domain and range. So a lot of information that we did. So notice that these other two questions, like number 2 down here or to the right, looks almost identical to number 2 right here on the left. Go ahead and practice that. Number 1 looks almost identical to this number 1 because it is identical. I messed up. I gave you the same one. But still, it's a good idea to try it again. And if you get stuck, just look at this work that we did over here. Once again, the main lesson for yesterday and today is to be able to find the vertex, then to be able to state your axis of symmetry, and then be able to state the y-intercept by setting x equal to 0 and solving for y. And then you could map it over to the other side. Or from the vertex, if your a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9, 1, 1, 2, 4, 3, 9. It's off the graph. Map it over to the other side. You have your entire parabola. Okay. Don't forget about your domain and range. So please work on these two questions for homework. And tomorrow, we're going to work on these next ones because look at the a value here. The a value is not 1. That means you cannot use the pattern 1, 1, 2, 4, 3, 9 as is. Tomorrow, we're going to learn how to know how to modify the pattern when a is not 1. Like if it's 3, we'll be able to modify it. If it's 1/2, we'll be able to modify it. But that's tomorrow, not today. Okay. Today, work on these two questions right here. I hope this helps.